So today, I hope now the screen is visible. Recording started. So in the last class, we had just basics of Nexus switches covered. We have discussed about basic CLI. Just a minute, please. Okay, so in the last class, we have discussed about basic CLI, and we have seen basic. You guys, I hope you guys remember about bootable image. By default, the bootable image is not set, so the device was going in a loader mode, right? So then what we did, we have also set the bootable image on our Nexus switches. Today we'll be exploring the hardware part of the Nexus switches. Today we will be exploring the hardware part of the Nexus switches. Yes. Hello. Hi. Hello. Who is this? Hello. Yes, Sahil. Hello, Sahil. Yes. Mhm. Yes. So see, for the first time, we always access the switches using the console port. Yes, of course. No, see, console port is available on all the type of devices. Either it is a fabric or non-fabric. You will always see a console port. Okay. No, that's not possible. See, you must have an access port, sorry, the console port, but you'll see sometimes the console port is not in RJ45, sometimes it's in USB format, sometimes it's type C port, but the switch always have a console port. Either it is a fabric switch or non-fabric switch. So you will always see a console port. Please look closely to the physical switch and you will see that switch is having a console port. Okay. Okay. Please mute your mic, Sahil. Thank you. So in the last class, this is what we have. So basically, you remember on day one or on this class, I think we were talking about this, that on the Nexus switches, okay, the next you joined the last class. Okay, so the Nexus switches are having two types of operating system. One is known as NXOS, okay, and the second is known as ACI OS. So by default, the Nexus switches are running in NXOS mode. It means each and every switch will be configured or managed individually. Each and every switch will be configured and managed individually. Let's say if you have 10 Nexus switches, so you'll configure Nexus 1, then you'll go to Nexus 2, then you'll go to Nexus 3, then you'll go to Nexus 4. But that's not a scalable format because in data center networks, we can have hundred of Nexus switches. So I can't manage them one by one. So what I want a centralized controller. I always want a centralized controller. So in that centralized controller, what we do, we install the ACI OS or ACI operating system. And inside this ACI OS, we will be having a controller which is known as APIC. So in ACI, the topology is known as ACI fabric. The topology is known as ACI fabric. And in that ACI fabric, we have the switches running in the ACI OS mode. So we have this is called ACI fabric. So when the switches are managed by the APIC controller, they are called that the switches are in fabric. Yes. All right, great. So that's the switches in ACI fabric. Is there any questions, guys, from previous class? Please feel free to ask. All right. So just for a quick revision, this is what we have discussed in the last class. We were having a Nexus switch. Then we have seen a ping packet through the Nexus switch. We have seen the MAC address table on the Nexus switch, unknown unicast flooding. After that, we have discussed about loader mode. What is the loader mode? In-band management, out-of-band management, and how to set the bootable image. So this is what we have covered in the last session. So today we will be exploring the hardware part of it. We will be exploring the hardware part of the Nexus switches. Now earlier Nexus switches, we are having Nexus 2000 series switches, okay, in Nexus. Then in Nexus we have Nexus 3000 series switches. We have Nexus 5000 series, and then we have Nexus 7000 series switches, as well as we have Nexus 9000 series. So whenever you look at the switches, in the Nexus switches, as per the requirement, you will always see that we have different platforms. We always have different platforms in Nexus switches. It totally depends on your requirements. Now, with time, what Cisco did, the devices becomes end of life, sorry. Okay. And then there's a concern related to end of support also. Let's say one of the switch is not performing well. Let's say nobody is ordering Nexus 5000 series. So after a certain period of time, the Cisco will say, okay, now this switch is end of life. You can't buy it. You can't buy new switches. But if you already have these switches in the production network, we will be giving you support for next 3 years, let's say. After 3 years, we will not be giving you support as well. So you can't purchase new. Let's say from 2026, you will not be able to order new Nexus 5000 series, and in Feb 2029 your switches will also be end of support. So for this 3 years of period, we will be giving you support, but after that support will not be given. So you can plan your network accordingly. So how you will get the latest information that which switches are available and which switches are not available. The switch is available in the network or not available. So for that, we go for the cisco.com, the official website of Cisco. Here you will find the authentic information. You go to the product and services. In the product and services, you go to the networking and you go to switches. Okay. In the switches, I'll go to data center and cloud switches. Now you see here, explore data center and cloud switches. So you see we have Nexus 3000 series available. We have Nexus 9000 series available. And 9000 we have 9200, 9300. Then we have 94 also, 95 also, 98 also. High density and transport, ultra low latency. We have Nexus 3550, 3550. Storage area network, we have the MDS switches. I'll tell you the difference between the MDS and the Nexus switches. Then you see Nexus 9300. So in this portfolio, you don't see Nexus 7000 because Nexus 7000 switches are end of life now. Nexus 7000 series end of life. You see, the Cisco Nexus 7000 series switches are largely in their final life cycle stages, with most hardware including 7700 chassis and AM series and F series modules reaching end of sale in 2023. End of sale in 2023, and then they have end of life also, or end of service also, which is February 28, 2027. So there's always an end of sale and end of life announcement. So that's why nowadays you will not be able to purchase 7000 series Nexus switches. So you have to look for this. Okay, nowadays only Nexus 9000 series switches are in high demand, and they are deployed in almost all type of deployments. Either you can deploy them in standalone mode or you can deploy them in a fabric, but you will always see that we are deploying Nexus 9000 series in almost all types of net in 2025 or 2026. Now when you see this, whenever you have the Nexus switches, here I have a document in which we have the hardware related information. Yes, so let's say I hope it's visible. Here we have a product line of the Nexus switches. Here we have the product line of Nexus switches. Let's say you have Nexus 9500 series, Nexus 9300 series, MDS, Nexus 3000 series, Nexus 2300, and MDS 91322. Okay. Before going further, first of all, let's understand the difference between two types of Nexus switches. You have fixed switches in Nexus family, and you have modular switches. What do you understand by this, guys? What do you understand by fixed switches and modular switches? Any guesses? You want to guess? Okay. Very good. So we have two types of Nexus switches. We always have the fixed switches and then we have the modular switches. Like you said, guys, all of you are right. You got very interesting point about the switches. So the basic difference is that in the fixed switches, we don't have options to add any modules. Add any modules. So fixed switches, or you can call them fixed switches. The fixed switches the fixed switches are having set of ports and typically cannot be expanded. So like all of you guys said, that's true. The fixed switches are having a set of ports and typically cannot be extended. But when we talk about modular switches, the modular switches allows us to upgrade and add modules to increase the port capacity of a switch. These switches are also known as chassis switches. These switches are also known as chassis switches. So we call them chassis switches as well. These switches are also known as chassis switches. That's the major difference. Now, if you look at the database of the Nexus here, the official website, data center switches, you see that we have the fixed switches. If you look at the fixed switches, Nexus, let's say 3000 series switches, we'll talk about their components also. We'll discuss about it. But in this, you see, in 3000 series, we have Nexus 3600, 35, 34, 32, 31, and 3100 virtual switches. So if I compare Nexus 36,000 series switches, in this you see we have Cisco Nexus 3048. Okay. Likewise, you have Nexus 3132, 3164, 3175, 3172, sorry, 3172, 3172, and 31128. So we have limited number of interfaces, and those interfaces cannot be changed or you cannot enhance them. But on the other hand, if we go to the modular switches, in the modular, let's say if we go to 9500 series switches, in the 9500 series switches, you will see that we have switches like this. So in the switches like this, the image is not clear. Okay, let's take a screenshot here. So these kind of switches, they are the modular switches. We can add module to them as per the requirement. Here, you see that this is a chassis. Inside this chassis, you have installed one switch, this one, 2, 3, and 4. So we have 4 switches here, right? And in case of chassis switches, you know, we don't call them switches, we call them line cards. We call them line cards. So these type of switches are known as the modular switches. I hope this part is clear to everyone. Any challenge between fixed switches and modular switches? Great. But there's a very interesting part of the Nexus switches, guys. If you look at Nexus 9300, you see a name. Let's say you see Cisco Nexus 3164Q. If I tell you, okay, if I give you this name and I ask you guys, please give me some specification of this switch. Please tell me something about this switch by just look at it name. What you would say? Okay, okay, very good. So you guys said very right, right? It is a switch with, it means it belongs to, first of all, it's an access switch. Okay. Then it belongs to the switches series of 3000 series. In 3000, it's one of the platform which is 310. And in this we have 64 switch ports. We have 64 switch ports. What do you think, guys? What is this Q stands for here? So it holds a meaning, guys. It's not, you know, it's not random thing. If you look at this, if you look at the documents again, you see 9372 PQ, you see TQ, you see PQ. So it means that it's not a random stuff. It always holds a meaning. So for this, we have a document here. Yes. Please pay attention here. So this is the meaning of these characters here. If you see here, the character is Q. Q means this switch is having the interfaces with the bandwidth of 40 Gbps. If you look at the data sheet, you see it has 64 Q. Q means quad. Q means quad, guys. And all of you know quad means what? 4? Yes or no? So it means if you look at this, this is a quad. Okay, let's take an example of another switch. We have this one. It means this is a switch. Okay, this switch belongs from 3100 series. It has 72 switch ports. After this, you see T. T means 100 Mbps, 1 Gbps, or 10 Gbps. It means on this switch we have the interfaces and their capacities are up to T means 100 Mbps, 1 Gbps, 10 Gbps. Q means quad 40 Gbps. Okay, so this particular switch is having the switch ports. They can have bandwidth from 100 1 to 10 Gbps, 100 Mbps, or the same switch can have the interfaces, because one switch can have interfaces with different bandwidth. Q means 40 Gbps. You will say, okay, that's fine, but what is this XL? Here you see XL, right? We don't see XL here. So this also has a meaning, guys. X is for this and L is for large size deployments. So see, okay, we can't put it here. Let's take it to the next slide. If you see X, it means that this particular switch is having more analytics capabilities. It can have more analytics data. If you see enhanced, if you see E means enhanced, F means it supports the max security, and if you see G, it means it supports 400 Gbps links. It supports 400 Gbps links. Okay, so these are the options we have. And if you look at this L stands for, it is mainly suited for LAN networks. Hello, please mute your mic. Please mute. You understood now what, how is this name is, right? What is the meaning of this name? Of course, you are in the WhatsApp group. Yeah, so we have shared the notes from the last class and I'm going to share it also. Okay, but it makes sense now. Very good. Okay, very good. Sure, it's in the chat box. Okay, this one. Actually, I was also about to come to this example. This is very interesting. Okay, so in this case, if you look at this, these are the names, right? In this, if you look at this, it's 93. It means the main series of the switches is 99,000 series, but it is from the 9300 series family. But after this you see 108. So does it means that this switch is having 108 interfaces? No. It does not mean that this switch is having 108 interfaces. Okay. So what does this 108 means? This time the 108 defines total bandwidth supported by this switch. Total bandwidth supported by this switch 108. But even not it's 108 Gbps. It means something else also. So let me explain it to you guys. What does it means? What does it means? 108. Okay. So I got a document here. Just a second, guys. Okay. So this time this 180 or 108, they don't define the number of interfaces. YCFX. So in this case, this particular switch is having what? YC. Y means what? Y means 10 to 25 Gbps. So the maximum bandwidth is 25 Gbps. C means what? Maximum is 100 Gbps. So this particular switch is having what? This particular switch is having 48 interfaces, each with 25 Gbps, because maximum it can go up to 48 interfaces and each of them is having 25 Gbps bandwidth. Plus the switches are also having uplinks, and it has 6 uplinks with 100 of the bandwidth. So if you combine it, totally you will get 1800 Gbps of throughput. So always remember this. If you see something like this, a naming convention 3164, if you see number like this, it means it has the total number of switch ports. It defines the total number of switch ports. But if you see numbers like this, 180, 108, 180, so it means that that particular switch is not showing you the number of the switch ports. It is trying to convey something else. 180 here, it means that the maximum bandwidth supported is 1800 Gbps. But we can't put it like this 931800. No, so they simply made it 93180. They simply made it 93180. That's what it means. Okay, so that's how here we have 93108. So if we look at this 93108 here, 9300 series. Yes, here we'll find it. Nine three So I think you posted it. It's not 93108. It's 938180, right? FX3. I think this is the switch, right? CPU management port. So this must be the information with the console also. If it is possible, can you share the photos with us in the WhatsApp group? Rear photos and the front end photos. Okay, so it should have a console port, guys. I never saw a switch without a console port. All right. So that's how the names are, and I hope now you guys will be able to make meaning out of it, that why this specific name is given to a switch. So the name is self-explanatory. Okay, the name explain itself. Make sense, guys? Sorry, come again. Yeah, so they call it you are talking about the name. So they call it taxonomy actually. The taxonomy of this, like that's the word used here. Okay, that how we got this name. Yeah, so I hope till now it makes sense. Now we'll go to the switches hardware level stuff, and we'll discuss about that. But unfortunately the labs are not available today, guys. Okay, please mute yourself. Hello, not speaking. Thank you again. Okay. So you guys will not have a pleasant experience. Now let's talk about it, the hardware part. Okay, so here we have the product lines. Now I think I gave you a explanation of the Nexus switches and the MDS switches. What is the difference? Okay, so like data center network is mainly built on three technologies. So in the data center network you will find compute, you will find network, and then you will see the storage. So you have the compute resources, you have the network resources, and as well as you have the storage resources. And then for the data center network, Cisco offers us two type of switches. The Nexus switches, which we use to build our ACI fabric or non-ACI fabric, and then we have the MDS switches here also, which is MDS, multi-layer director switches, multi-layer director switches, MDS. By the way, the MDS switches are based on the Nexus switches itself, but the MDS switches are specifically designed for storage area network. Designed to build Ethernet networks. So MDS switches are, the functionality is almost similar to the Nexus switches, but they are specifically designed for storage area network, guys, because we are connecting storage appliances. So for that we have the MDS switches here. Okay, make sense? By the way, it's not our cup of tea, okay, and we are not supposed to discuss about this in detail, but in the storage area network we use a protocol which is known as fiber channel. And the addressing is also different. We don't use MAC addresses in the storage area network. There we use the fiber channel and fiber channel addressing also. We use the fiber channel addressing also. I hope it makes sense now. Okay. Then next 9500, 9300, 9706, 3000 series, 2300 series, and 9138. So here we'll not be focused on the MD switches mainly, guys. Our focus will be on the Nexus switches. And in this particular image, you can see we have the Nexus switches. And in this we have two types of switches, the modular switches and the fixed switches. So these are the modular switches and these are the fixed switches. If I ask you one more question, guys, okay, you guys might be thinking that you are asking a lot of questions, but that's my way of teaching. Okay, I just want to make sure we are on the same page. So you see here, you see the switches, 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 but here you see Nexus 2300 series fabric extendeds. Why we don't have Nexus 2300 series switches? Why we are having this concept of fabric extendeds? Why not Nexus 2300 series switches? What is the difference, guys? Any guesses? Yeah, so thank you for the insights. But see, this Nexus 9300 series, why we call them fabric extended? Because let's say you have this main switch, the 9500 series switch or 9300 series switch, but we have very limited interfaces. What we want just some extra interfaces, extra ports, but we don't want a full functionality of a switch. We just want to extend so that we can have some extra ports, but we don't want a switch. It's like having a this is your, let's say, main house, right? And then you said, okay, we have guests, so let's build a guest house also. So in the main house you have 5 bedrooms, you have a swimming pool, you have a theater, you have everything, but in the guest house you just have 2 rooms. So this guest house is what? It's just an extended stay so that you can have your guest over there. Likewise, if you have requirement of few extra interfaces, but you don't want a full switch, because if you have another switch, you have to manage that switch also. So that's the difference between this fabric extended and the main switch. In that case, this switch will be act as parent switch, and from this parent switch itself, you can manage your fabric extendeds. So the fabric extended switches were designed for this purpose of a fabric extend. And mostly these switches are used as top of rack also. These switches are used as to simplify the cabling structure, guys. I don't want to go that side, but I just want you to have understanding so that you guys don't get confused. A Cisco Fabric Extended, typically the Nexus 2000 series, act as a remote line card for parent who can act as a parent. 5000 series, 7000 series, 9000 series switches. It simplifies data center architecture by reducing management points, acting as a single distributed modular system that extend the network fabric to the rack level. So in the data center networks, so simplify the cabling structure, we have a strategy which is known as top of rack. We have a strategy known as top of rack. Let's say in a rack, you have multiple servers, server 1, server 2, server 3, server 4, server 5. Likewise, you have another rack. In that rack also you have multiple server 3, 4, 5. And then you have the main topology. This is my spine switch. We'll discuss about spine and leaf architecture, don't worry. And this is my leaf switch, leaf 1, leaf 2. So it's not possible to connect all the servers directly to the leaf switch due to the cable length, as well as it's going to make it complex. So we have designed a concept of top of rack switch. So in this case, we will be having a switch on top of this rack, and all the servers will be connected to it. Top of rack, and all the servers are connected to this. First of all, it will simplify the cabling. Second, now top of rack is connected to the leaf. So you are not consuming all the interfaces of the leaf switches. So that's the idea behind the fabric extended, and that's why we call them fabric extended, not the switches, because they are not having the functionality like a switch. Make sense, guys? Please give me a confirmation that this information is clear to everyone, that why do we call them. Yeah, like you said, yes. Okay, so then we have the empty switches. Like I said, this is for the storage area network. Then Cisco Nexus operating system and Cisco Nexus form factor. So we have already discussed about the form factor, modular and fixed. But in Nexus 9300, the Cisco Nexus operating system, I will share this PDF also. But here you see, if you have Nexus 9500 series, Nexus 9300 series, they can operate in NXOS mode or they can operate in ACI OS mode. Is it clear, guys, to everyone? The difference between NXOS and ACI OS? Great. Then we have Nexus 7700 series, Nexus 300 series. They don't support the ACI, so they can only have one type of operating system. And that operating system is known as, what we call it? Nexus OS. They can't have the ACI OS, guys. They cannot be managed by the ACI. They are managed manual. Yeah. Then you have the Nexus MDS. They have their own operating system. So only Nexus 9000 series switches are supported by ACI. These are the switches which are supported by ACI also. Otherwise, rest of the Nexus switches run on only what operating system? The Nexus operating system, or the NX OS, or the NX OS. I hope it makes sense. Okay. All right, guys, that's great. Please mute yourself. Who is this? Again, I think it's Abhishek. Okay. Then let's proceed next. In Nexus categories of the switches, we have the fixed port Nexus switches, which is mainly in the Nexus 9300 series. In the 9300, guys, you will not see modular switches. They are fixed. We have chassis in 95. We'll discuss about that. So in the 9500, we have switches like 9504, 9508, 9516. We'll discuss about it. That In 9504 we have 4 line cards, we have 8 line cards, we have 16 line cards. But before that, please pay attention here. The fixed port Cisco Nexus 9300 series, we have the switches here. 9300 with the interfaces 40 gigabit Ethernet. Then we have Cisco Nexus 9300 with 40 and 100 Gbps, 110 25 Gbps and 110 basic switches. Then we have Cisco Nexus modular switches. So okay, we have already discussed about it and I explained the difference between the modular switches and the fixed port switches. Now this one is the modular switches. This one is the modular switches. So you look at this 9504 1 2 3 4. We'll also discuss about this. We have system controllers and other components. We'll discuss about it. The fans, the power supply units and everything. Then this is 9508. Why we call it 9508? 1 2 3 4 5 6 7 8. And then we have 9516. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So guys, you can imagine the number of switch ports. Okay, you can imagine the number of switch ports. Then how much space it's going to take in the rack? 7 rack units. Mostly if you talk about the fixed switches, they are 2 rack unit. Most of them, they just take very less space in the rack. But this switch is going to take 7 rack units. This switch is going to take 13 rack units. And this particular switch is going to take 21 rack units. This particular switch is going to take 31 rack units. So you can just see. And what do you think, guys? Is it possible for us to carry this switch? You can see the weight. If I show you the weight of this switch, the weight of this switch is 87 kgs. I know most of you guys might be working out daily and might be doing deadlift in the gym, right? Or squats, but lifting the 9516 switch with weight 87 kgs, it's very difficult because you don't have the symmetry to hold it. The 9508, the weight of the switch is 68 kg and it's 38 kg. So you can imagine how much weight they have. Then the total throughput at us in 1 second, 15 terabytes per second. This entire chassis can handle this amount of traffic. This entire chassis can handle 30 Tbps and this chassis can handle up to 60 Tbps, terabytes per second. So you can imagine their capacity or their power. You can imagine their capacity or their power. 9500 series switches. So I hope it makes sense now. Then this is how it made. In this we have support up to 4 line cards. So we don't call them switches. Like I said, the components, the devices which are having those interfaces or the ports, they are known as line cards in a chassis. Because this one is not having anything if it is not part of the chassis. So that's why we simply call them line card instead of calling them the switches. Instead of calling them the switches, we call them line cards. So in this we have 4 line cards, in this we have 8 line cards, and in this we have 16 line cards. In this particular chassis we have 16 line cards. Then up to 4 power supply. Your voice is breaking. Yes? No, it has most of the time they're used as spine switches, as well as the leaf switches. So basically, if you need a lot of interfaces, then you can go for these switches. You know what are the benefits of it? You will have a single management. Let's say if you have 16 switches separately, right? So the management is difficult. Now, in this case, the entire switch will be managed as just one switch with, you see, all the interfaces. Okay. Hello. So that's why, yes, the purpose is the no, in this case, all this is just a complete switch. This is a chassis, so it is managed as just one appliance. Spine does not manage anything, guys. Spine is also a layer of switches. When we'll discuss about this network architecture, so spine switches does not manage anything. The spine switches is a layer of switches. They don't manage the leaf switches. Okay, they're also switches. So this is a network architecture. We'll discuss about it. Then here you see that we have four power supply units. You see in the front of it 1, 2, 3, 4. Because you can't be dependent on just one power supply. If I share you one of my own experience, like in 2017 when I've started my CCNA training, then I saw the routers and the switches, like 3500 series switches, the Catalyst one. You know, we are always talking about network redundancy, that you must have redundant switches, you must have redundant switches, you must be running redundant default gateway. But the problem with this Catalyst 35 is it's just having one power supply unit, PSU, just one power supply unit. That's the problem. Because if that power supply is gone, what is the meaning of having redundant switches? So that's why in data center networks, you see all kind of Nexus switches. They always focus on having multiple line cards of, sorry, the power supplies. Then we have up to 3 fan trays, or you can have 2 fan trays. So you see in this case we have total 6 fan, 1, 2, 3, 4, 5, 6 for the cooling purpose. But the fans are not enough. The fans are not enough. Along with the fans, we also have the cooling system. The switches are placed in a very cool environment. So you have air conditioning rooms and all for the cooling. Then we have 2 supervisor, 2 system controllers, and 6 fabric modules. So 6 fabric modules are used to install these chassis or these line cards. Install these line cards in the chassis switches. So basically these fabric modules, you see that these are the line cards, right? They are separate. They're separate components. Who will hold them together? Who will hold these all line cards together? And who will make sure that they have same data forwarding? So the fabric modules in Cisco Nexus switches, they act as the central high-speed switching backplane, interconnecting line cards for data forwarding. Interconnecting line cards for data forwarding. Because you have these line cards, you will install them into the chassis, but who will hold these line cards together and how the data will be forwarded among them? So that's possible because of the fabric modules. I think we have the fabric module here. How does it look like? Just a second. Yes. Do you see it here? This is the fabric modules. I'll be sharing it. I will be sharing it. Okay. I'll be sharing it. No worries. Then Nexus 9508. So here we have the interfaces. One, okay, let's come back to the information here. Then you have two system controllers and two supervisors. So you see, in the normal Nexus switches, you have a CPU, the central processing unit, who take care of everything, who take care of the management related traffic, who take care of the power supplies, how much power is given to the switch, and manage everything. But in this chassis, we have these components: the system controller and the supervisor. System controller and the supervisor. System controller and supervisor in Nexus switches. So what they do, this is what their responsibility is. In Cisco Nexus switches, I'll be explaining it, guys, don't worry. So this is number one use case. This is number two use case. This is number three use case. Then supervisor module, number one use case, number two use case, number three use case. So in the Nexus switches, in Cisco Nexus switches 9507, the supervisor module manage what? Manage the control and data planes configuration and layer 2 services. While the system controller offload chassis management, like managing fans, managing power, managing environmental, and provides the gigabit Ethernet out of band management for the communication between the modules. So, and you see that we don't have just one supervisor module. We have two supervisors and we have two system controllers. So the system controllers, where's the back view of it? Rear view. Here it is. You see in the front of it, we have the supervisor module in the front of the switch. And in the back side, we have the system controllers. So now to managing this whole chassis, it is like managing a full team, guys. You are like, you have started a business. So you are self-employed. You are just one person team, okay? You do everything. Then you see that your business is growing. And once your business start growing, then you have a big team. And managing that team will become a headache if you'll do it by yourself only. So instead of managing it by yourself, you start hiring people. Okay, you are the manager. So you are responsible for hiring. So you'll hire new people. Likewise, in this whole big chassis, you can't just be dependent on the central processing unit to do all the functions. To do all the functions. That's why we have these two components. One is the supervisor module, which manages the control and data plane functionalities and configurations, while system controller manages the fans, power, like temperature and all these informations, chassis management, out of band or protocol packet communication, redundancy. We have two system controllers operate in active standby mode to prevent single points of failure. Likewise, supervisor modules. In supervisor modules also we have the high availability. Instead of dependent on just one supervisor module, we have two supervisor modules. We have two supervisor modules. Make sense, guys? Any questions here? Please feel free to ask. In this part, what is this component? The system controller and the supervisor. Sorry, come again. Speak louder, please. No, we don't have to configure it. We don't need to interfere here. It will automatically go to the redundant one. Okay. Any questions, guys, here till now? Okay. And then we have the fan trays. So, yeah. What? It's predefined. You can't select it. It's already there. Yeah. It's already in the chassis. Okay. So if you look at the data sheet, this is the best source of information because that's the we can say confidential or not confidential but authenticated information because it's on the Cisco modules. You see up to six fabric modules. We have the same fabric modules in the backside which connects all these line cards together. All right, guys, let's come back to this. So we have these components. Either it is 9504, 9508. The only difference is that in 9508 you have 8 line cards. And how many power supplies you can have? 8 power supplies. So you look at this. You can imagine the redundancy. Right? And in data center networks, guys, I'm not sure you guys might have heard of it or not, but in data centers or in highly redundant networks, we have a special device which is known as UPS. You guys know about it? Right? Uninterrupted. Yes, please. Your voice is breaking a lot. See, there's no such like you need to give 4, but yes, you must have redundant at least. If the switch is at the maximum level of the load, then you can give extra powers so that it's not running out of power, or sometimes we use power over Ethernet features as well. So in that case, it's always a better idea to supply the maximum power to the switch. But it also gives us the requirement, the power supply requirements. Here it is, just a second. This is required, maximum power. 80 watt, 80 watt, 80 watt, 80, 90 watt. So if you are able to supply 90 watt, that's great. Okay, you don't need to have all the power supply unit installed. And in the data center networks, when we use this UPS, uninterrupted power supply, so if this is an access switch, so you will make sure that the power is also coming from different UPS, UPS 1, UPS 2. So you have 2 power supply units, let's say. So one power you're giving from UPS 1 system, second power you're giving from UPS 2 system. Because if entire UPS system crash, then still you have the redundant power. Okay. Then these are the components we have discussed about it. Yes, that's are the options. If you just dismantle your chassis, it will look like this. The fabric modules, the supervisor, the system controller, the power supply units, the fan trays, and the line cards. And here we have a feature in the power supply units and in the fan trays. So in the fan trays, guys, we have a feature which is known as hot swappable. I don't know if that's the correct spelling or not, but hot swappable means in a running device you can change the fan trays. In a running appliance you can change the fan trays if the fan trays are not working properly. Then it is possible to change those fan trays. That's possible. Okay. Any questions here? Please feel free to ask. Or shall we proceed next? Sorry. RMA means Cisco TAC, right? Or Cisco RMA? Yes, you can. Yeah, yeah, you can check the components. See, usually what we do, let's say fan is not working. So first of all, you check it by yourself. You just jack out and jack in, like you remove it and then you place it again. If it works, great. Otherwise, you check the command like show environment fan, if it's working or not. Then you locate the product ID. So it's not having a serial number. We call it a product ID in case of a fan trace. Then yes, you can reach out to the Cisco tag for your return material authorization, like RMA. That's the full form, I think. Return material authorization. So you can apply for that. Yeah. Yes. No, they are not equal. They are different. We have two supervisor, two system controllers. Yes. For the It's a standard for the redundancy purpose. You will see them installed. We can't have more than that. Okay. Yeah. You're welcome. This is 9516. So we have 9504, we have 9508, and then we have 9516. So we have three switches in the modular 9508, 9504, 9516. Then these are the line cards. What are these line cards? The line cards are mean the this which you installed in the chassis, which you installed in the chassis. So instead of calling it a switch, we call it a line cards. So if you call it a switch, it means it's a fixed switch. But when you use the term like line cards, it means we are talking about chassis. If you say line card, it means you're talking about chassis. So we have chassis as well as we have the line cards. We have the chassis as well as we have the line cards. So in the line cards, you have different options as per your requirements. Let's say this is one of the model 9K9560PX. So if you see PX, P means what? P means okay 1 to 10 Gbps. 9560. So we can have 1 to 10 Gbps SFPs. We have 4 ports for the uplinks, which are quad SFPs. And this particular line card supports both the modes, NXOS mode and as well as the ACI mode, Then here you have Nexus 9K 9560, sorry, 9564TX, 9564TX. This is also one of the line cards available here. So now you guys would be surprised to see that we have the line cards with the capabilities up to 400 Gbps. 400 Gbps. I'll share this slide. Sorry, this one. So basically, see, if you have one switch port, okay, and one switch port is equivalent of having 25 Gbps, and that switch is having 48 interfaces. So 48 into 25, it's 1200 Gbps, or you can say 1.2 Tbps. Okay, so that's how you can calculate the total throughput. It totally depends on the number of interfaces. Like here the example is this is the switch we were having this discussion here, 93180. So 93180 means this switch is having 48 interfaces, maximum bandwidth 25, and 6 uplinks, and each of 100 Gbps. So 48 into 25 is 1200 plus 600. So total throughput you're getting 1800 Gbps. Okay, so that's how you calculate it. These are the line cards, guys, in the 100 Gbps fiber line cards. So I'll share this slide with you, this particular PDF, and in this particular PDF all the details are given related to the line cards of 100 Gbps. You can look at the throughput, the number of interfaces, ACI supports is given on note. Because if you are going to deploy it, first of all you will be having a set of requirements from the customer, that this is what we want to achieve. This is what we want to achieve. And if your switch supports it, great. If your switch supports it, then it's great. You can just use it, and you can deploy it. Then supervisor modules. These are the hardware components. You look at this, the supervisor module is having the console port. We have the USB port also. Okay guys, tell me something about USB port. What we can do using a USB port on the switches? Yes, we can put the OS. We can also take the configuration backup on the USB. Very good. Then we have redundant paths to system controllers. You have the SSD, the RAM, the console port, the management port. Management port is used for remote access. On the management port, I can configure an IP address, and then I can use telnet and SSH. Then I can use. No, it's not possible, I think. But yeah, okay. As we can see here, we have the modules, right? Yeah, we can expand it. So we have only 3 slots. That's the maximum capacity. So you get only 3 units. Okay. See, it's given here 60 GB memory is supported maximum. Okay, but you can make it less, like you can have 2 units of RAM, or maximum you can go up to 3 units. Okay, Then this is the supervisor modules, and these are the options we have. Like if you have supervisor A plus, maximum you can go up to 16 GB, but in supervisor B plus you can go up to 24 GB of RAM. Okay, so if you want to have extra RAM, then you can go for supervisor B plus. A plus is going to support maximum 16 GB of RAM. Maximum 16 GB of RAM. Okay, storage. So we have SSD here, 64 GB of SSD, and supervisor B plus you can have 256 GB of storage. The fan trays, the very interesting part, right? And if you guys have deployed it, I've deployed it in a data center network, and once you start the fan, they make a very loud noise. After some time, they just reduce the noise, but yes, you see in the back end of the switch, you will see that air is coming out of the fans. Fan trays. You can have 3 fan trays with 2 fan per trays, front to back airflow through chassis. Dynamic speed control driven by temperature sensors. Straight airflow across line cards. 2 plus 1 redundancy per fan trays and per chassis means you need at least 2 working fan trays. Plus 1 is the latency, sorry, plus 1 is the redundancy purpose. But at least you must have 2 running fan trays on this switch. System controllers. The Cisco Nexus 9504 switch has 2 redundant system controllers located at the rear of the chassis. And the system controller is responsible for chassis management, including the fan speed control, power supply management, and out of band control plane. We have already discussed about it, but that's how it looks like. Then these are the fabric modules which connect all the chassis, all the line cards together so that they can start sending and receiving data with each other. Otherwise, you see, they're independent switches, but how they'll connect it together? So they will be connected in the chassis using the this fabric modules. Each fabric module provides up to 5.12 Tbps of bandwidth and is connected directly to each line card in the chassis. Customers needs all 6 fabric modules to provide non-blocking performance for the 36 port 40 Gbps to SFP line cards. That's how they are connected. Okay. Naming conventions, we have already discussed about it. The naming convention like 93108 TCFX. So 9300 series 1 to 10 Gbps switches the data information, guys. I hope you guys can go through it. So you see that in this particular switch, why we got this name 108? That's the main reason. So in this particular switch, you have 48 interfaces. Maximum supported bandwidth is 10 Gbps. So they can give you 480 Gbps plus you have 6 extra interfaces. Okay, guys, do you guys understand the difference between uplinks and downlinks? All of you? Yes, connected between switches. And the downlinks are connected between, sorry, connected to the endpoints. So you always want the uplinks. Uplinks should always have the high bandwidth, because if I go back to the design, we haven't discussed about the network architecture, but if you look at this, let's say there are multiple servers connected. So the bandwidth of this interface is dedicated for this user, but the bandwidth of this interface is shared. So the bandwidth of this interface or this interface should always be higher than these interfaces. That's why we call them uplinks. So in this particular switch, we have 6 uplinks, and each uplink support 100 Gbps. So you have 480 Gbps for the downlinks and 600 Gbps for the uplink. So total bandwidth is 1080 Gbps. But we can't make the name like 931080. So we drop the 0 here and we said 93108. In this you see 9348. It means all the interfaces with the same bandwidth. 93108. Then you have 93216. So you can imagine the total throughput 216. So this particular switch is having 96 interfaces, each with 10 Gbps. So 960 Gbps and 12 interfaces as uplinks. So 1200 Gbps. So total is 2160 Gbps. Total is 2160 Gbps. Yeah, you can calculate it on every switch. Once you look at the name of the switch, you can calculate it. See, it's only required if you have the interfaces with different speeds. Let's say you have 9348. So it means that we have 48 interfaces with all the interfaces with same speed. When the switch ports are having different bandwidth, only then you will see names like this 108, 216, okay? Otherwise, all the switch ports are having same bandwidth. Yes. 9348 GC FXP, 93108, 9310 TC. This is the 9300 series switches, guys, with 11024 Gbps if you need that speed. If you need the switches with 40 to 100 Gbps, you have these platforms for 40 to 100 Gbps. And if you want 400 Gbps switches, then you have these are the options. If you see D, 9316D, what does D means? Remember? If you see D in the name, D represent what, guys? D represent 400 Gbps. Make sense? Yes. This is the SFP type. D means 400 Gbps. Yeah, for the 400 Gbps. Yeah. Then you have the Nexus switches with 400 Gbps also. Make sense, guys? I'll share this document with you guys as well as the notes. But that's all, guys. We'll wrap up here today, and in the next class our lab would be up and running, so we'll do some labs. Okay, but it was a quick session. I hope you guys have enjoyed it. You've learned something new today. I'll share